All right, so day 3, that's page 12 in your notes. And we're going to talk about the relationship between polynomials and roots. Important to remember that roots are x-intercepts. So let's continue with roots of polynomials. All right, so it's going to be important that you guys can graph these polynomials in your graphing calculator and create an appropriate sketch. So when sketching, you really want to make sure you estimate where the key features are in the graph, which would be the intercepts, both x and y intercepts, and any other features like minimums and maximums. Make sure to kind of place them roughly in the correct area. So a sketch is not a perfect graph where you have to put the actual points exactly where they go. A sketch is just a sketch, but it should still look like the function. Okay, so graphing these functions, these are a constant function or linear functions, which we should be able to just sort of sketch on our own without a calculator, hopefully. So y equals 2. Would look like that, approximately. All right, this is just a sketch. And negative 2x plus 1 would be, we'd have a positive 1 y-intercept and a negative 2 slope, so maybe something like that. Here we'd be at negative 3 and have a positive slope. Maybe something like that. All right, that's a sketch. So if you notice the constant function, which is a horizontal line, how many roots does it have? Roots are x-intercepts, or also known as zeros. So there are no roots there. So this would be no solution. This one has one root. And what is that value of that root? Well, that's when y is 0. So when y is 0, what would this function turn out to be when you solve it? It looks like negative 1 divided by negative 2. So it would come out to be positive 1/2. And then x minus 3 has, again, that has one root, one x-intercept. And that one would be when x is 3. Right? Also thinking about what number would we plug in for x to make the y value 0. Okay, so there's the roots. A linear function can have, at most, one root, because it's a straight line, right? Once it crosses the x-intercept, it can't bend and come back to the y-intercept. So it just has one root. A quadratic function, though, is a different thing. So for these, you're going to have to put these in your calculator and sketch them. So put them where they're supposed to be, approximately. I don't really have one of your graphing calculators, but I have Desmos. So I'll just bring up Desmos and I'll type these in. So you guys should be graphing this in your calculators into y equals. And I'm going to find the key features here. It looks like there's a x-intercept or a root here at negative 1 and at 4. The minimums over here are our y-intercept is -4. So we just kind of want to sketch these main features there so that it looks approximately the same. So maybe something like that. I don't know. It's not very easy to draw on this thing. Okay, next one, I'm just going to go into y equals and change the function. Okay, so it looks like I have my y-intercept down here. It's opening downward, and it just has one x-intercept. So maybe something like that. And checking the rest of these. So again, this one looks like one x-intercept, y-intercept here at 1, and it's opening upward. And then the last one, x squared plus 4. Again, you can put that in your calculator, or you can remember that that's just x squared shifted up 4, which would look like this. And this results in 0 x-intercepts. Right, so we saw with linear functions or constant functions, it could have 0 roots or 1 root. Here, what are our options? The first one has 2 roots, and then we see this one has 1, this one has 1, and this one has 0. So quadratic functions can have at most 2 roots. Cubic functions. Again, let's go ahead and finish sketching cubic functions and quartic functions. So making sure you can use your calculator correctly to produce the graph of these, and then sketching them appropriately. Okay, so you guys can go ahead and do that. If you want to pause, that's fine. I'll just keep going through this and sort of sketching what I see. All right, so this first one looks like we have a little maximum over on this side. Our y-intercept is negative. And then we have a local minimum over here and a positive x-intercept over there. Okay. So we get something like that. And I'm not going to type all of these in and sketch them. You guys can do that. Cubic functions can have at most 3 roots. Quartic functions can have at most. Hopefully you guys have picked up the pattern here. Quartic functions can have at most 4 roots. So again, sorry, just to point out those x-intercepts on the cubic. 1, 2, 3. But again, if we think about how it's shifted, it could have less than that, right? But at most 3. All right, for the quartics, let me put at least one of these examples in. I'm not really sure which one is a good one to do. I will do this. All right, so here's what we see for this quartic. That sketch did not come out very well. It's kind of trying to make that shape. It kind of messed up. But we get the idea, it's a sketch. Let me put in the next one as well. And here we see sort of this shape. Comes down, has one root there, a local max, another root, local min, and so on. So I'll try to sketch that out. All right, again, that didn't come out very good, but hopefully you guys get the idea. Why do you think that a cubic can never have 0 roots? So when I was talking about this cubic up here, I said it can have at most 3 roots, but if we shift it up or down, we could change that, right? So let me see if I can do that. If I take this and move it, it's going to move everything, that's fine. Right, I can move it so that there's one x-intercept, or I could move it like this and there's still one x-intercept, and because it goes from negative infinity to positive infinity, it will always cross the x-axis. So it goes back to that idea of the end behavior, opposite end behavior, right? If we start at negative infinity and end at positive infinity, then somewhere in between we had to have gotten past 0, okay? And again, that's because polynomial functions are smooth and continuous functions. So why can a cubic never have 0 roots? Because cubic functions have opposite end behavior. So it has to cross the x-axis at least once. And what are some other polynomials other than a cubic that will never have 0 roots? Well, based on our explanation here, opposite end behavior. So any polynomial that has opposite end behavior, that would be x to the 5, x to the 7, x to the 9, and so on. Okay, they will all cross the x-axis somewhere because they have opposite end behavior. So what was the pattern in terms of the maximum number of roots that we can have based on the degree of the polynomial? How does the degree and number of zeros relate to each other? A polynomial can have, actually hold on, let me reword that. A polynomial of degree n has at most n roots, or x-intercepts, or zeros. Okay, so a polynomial of degree n has at most n roots. So a polynomial of degree 5 has at most 5 roots. A polynomial of degree 14 has at most 14 roots, and so on. So what you guys are going to do is you're going to complete these questions. So they are giving you 3 different functions. You're going to identify the degree of the function, sketch its graph, so what we were doing before, and find its zeros. So you guys can go ahead and do that. I will confirm your answers to the degree and its zeros, and then you guys are going to do some work like we did last class here, adding and subtracting functions, so using these functions. All right, so using these same functions up here on these problems, as well as down here. All right, so let's go ahead and work through page 14. And you can pause now, and then when you guys are ready to check answers, you can unpause and I'll kind of work through it. All right. So f of x is a degree 3. Sketch its graph. So let's see what that would look like. Oops. Okay, there's its graph. And it has zeros at x equals -2, x equals 0, and x equals +2. Has 3 different zeros, and those are the values. Again, you can find that on your table in the calculator, right? Which x values make the y value 0, or you can calculate the zeros from the graph, right? Put in y equals 0 and find intersection points. All right, g of x. Gotta be careful with g of x. It's not written in standard form. So the highest exponent here is 4, so that's a degree 4. And what does that look like? Let's just change all that. All right, and kind of get this like W looking curve. And the y-intercept looks to be 0, and the maximum's on this side. So the zeros here are x equals 0 and x equals 4. So only 2 zeros there. It could have had a max of 4, right? If we shifted it down, it would have ended up with more. And then h of x Okay, and here we see an example of a quartic, so a degree 4, which has no roots. All right, adding and subtracting polynomials. So adding f of x plus g of x. Again, if you haven't done that yet, make sure you do before I go over it. So adding them together, you should have gotten, so I'm adding these two up here. So I only see one x to the 4. And then x cubes, I have negative 8x cubed and a positive x cubed. That would be negative 7x cubed squared. The only one is a positive 16x squared. And then minus 16x. And that's it. So there's our expression. That's what we should have gotten when we added those together. And then when we subtract f of x minus g of x, I'm going to write that out just because I don't want to mess up the signs. So there's f of x minus parentheses g of x. So that would give me x cubed minus 16x minus 16x squared plus 8x cubed minus x to the 4. And then combining those like terms, that means I get negative x to the 4 plus 9x cubed minus 16x squared minus 16x. So there's our answer for the second one. Part C, find the degree of these polynomials. So if I took g of x and subtracted h of x, g of x is a 4th degree, and we would subtract h of x, which is a 4th degree. So let's see if x to the 4 minus x to the 4 would be gone, right? That would be canceled. The cubed term, negative 8x cubed, and we were subtracting negative 8x cubed. So that's like adding 8x cubed, and so that would end up being canceled. Squareds, 16x squared minus 16x squared. That will cancel, right? Because if you notice, these are this exact same function so far, except h of x has a plus 4 at the end. And so if I take g of x and subtract h of x, all I'm going to end up with is that minus 4. So sorry, that the degree of that polynomial is actually a degree 0. Because all we're left with is 4. And so 4 is, sorry, negative 4. So negative 4 is x to the 0. So that's degree 0. If we take h of x and subtract f of x, h of x is a degree 4, and we're subtracting a degree 3. So that, I really don't have to think too much more about that. If I have a degree 4 and I subtract a degree 3, I still have a degree 4, because it didn't change anything with this term. All right, next page. So, zeros. Zeros and factors. This is called factorization. So, if you guys remember from quadratics, when we factor, the solution or the x-intercepts are the opposite sign of the factor, right? So this is showing an example here where x minus 6 is a factor, and so positive 6 is a root or a zero, right? If x minus 4 is a factor, positive 4 is the root. If x minus 10 is the factor, positive 10 is the root. So it's just reminding us that relationship that we saw in the quadratics, with quadratics, where the root and factor have opposite signs. So what we're going to do for these is we are going to write them in standard form or factored form. So depending on which form they give us, this one's standard, so we want a factor. And then we're going to use those factors to find the zeros and the x-intercepts, identify the y-intercept. Don't worry about doing this just yet. We'll do that with the quadratics functions. And then find any maximum or minimum points. So that you can do in your calculator. Okay? All right. So when I factor this, remember, check for GCF first. I can factor an x out. And to find your zeros, you just set each factor equal to 0. So x equals 0, x plus 4 equals 0. This one's done. This one I have to subtract 4. There's my two x-intercepts. The y-intercept, I look at the standard form. It would be out here. There's nothing there. The y-intercept is 0, 0. All right, any maximum and minimum points, you can do that in your calculator. Just calculate the maximum or minimum from the graph. This function would have a minimum at -2, comma, -4. I believe. I think so. Yeah. Okay. Hopefully that's what you guys got. All right. Next one. Factor. So again, you guys should probably pause and do these first, and then check what I'm doing. All right. With this, I'm going to factor the negative out first. And now it's sum product, so numbers that multiply to -6 and add to make -1 would be I believe a +2 and a -3. So there's our factored form. And so our roots are -2 and +3. Opposite signs on the roots. So there's our x-intercepts. Our y-intercept is 6 from standard form. Our min or max, this one will have a max. And go ahead and calculate that on your calculator. I'm gonna figure out what that is. I believe that comes out to be 1/2 or 0.5 and 6.25. All right, next one. This is already in factored form, so we just need to find the zeros. Right, like this one, x plus 5 is a factor, so I know that x equals -5 is a 0. This one, I might want to set equal to 0 first and solve. And so there's my two roots and my y-intercept. We have to distribute this to get to standard form. So I'm going to double distribute. It'll give me 2x squared plus 10x minus x minus 5. So that's 2x squared plus 9x minus 5. So the y-intercept is 0, -5. And the min max, this will have a minimum. And again, I'll let you guys figure that one out for me. And we can move on to the next problem. So go ahead and do number 2, and I will continue that when you're done. All right. All right, so number 2, what are the zeros? If you look at all of these factors, there's 3 factors. Don't forget about that x in front. So that would be x equals 0 from the first one. This would be x equals 3. This would be x equals -5. Write it in standard form means double distribute. So double distribute the parentheses first, and then distribute the x last. So when I double distribute the parentheses, I get x squared plus 5x minus 3x minus 15. And then I can distribute the x, or I can combine like terms first and then distribute the x. So x cubed is 5x squared minus 3x squared minus 15x. And so our standard form is x cubed plus 2x squared minus 15x is what you should have gotten. And what's the degree? This is a degree 3. And how do we know even before getting down to x cubed? We can see that there are 1, 2, 3 x's being multiplied together. So that tells me that that's a degree 3. Graph the function in your calculator, draw a sketch below, label the x-intercepts, y-intercepts, local maximums, local minimums. So to do that, remember you're going to have to just use your calculator to find min and max points, x-intercepts, y-intercepts, we should be able to identify from factored form. We have them right here labeled. We have a y-intercept that we can identify from the standard form because there is no constant term here, so the y-intercept would be 0, and so on. All right, so I'll let you guys finish that one. And when you are done with all of this, depending on how long you paused and took your time with these notes, you should have some time to get out your homework and start working on what is this unit? 4? Yeah, 4.3. Okay, so 4.1 and 4.2 should be done, and so now you can work on 4.3. And that's about it for today. I will see you guys next time.